Dear engineers, I engineer S. Kumar from Reinforcing India present here to introduce first part of ANSYS software. One of my viewers asked me to upload video on ANSYS. I will upload each and every concept regarding ANSYS. There are many videos available on YouTube, but they are not suitable for beginners. Friends, your comments provide me energy to upload more video. If anyone interested to take CAD model or problem statement PDF, can write in comment box. Today we will see the theory of 1D meshing. 1D meshing is used when one of the dimension of any component is very large in comparison to other two dimensions. Why we will focusing on this 1D meshing? Because before analyzing any geometry or model, we should be able to classify them as 1D, 2D or 3D. That's why it is important to go through theory of 1D, 2D and 3D meshing. What is the element size shape of 1D, that is line. Additional data, cross-sectional area, element type, rod, bar. Practical application is beam, connection element, long shaft. Deformation. Physical deformation can be calculated on and inside a part or an assembly. We all know that fixed support prevents deformation. Location without a fixed support usually experience deformation related to the original location. Deformation are calculated relative to the part or assembly global coordinate system. ANSYS give the following result: component deformation, whether we want deformation in x direction, y direction or z direction. Second is the deformed shape, that is total deformation, that is average deformation. We will see one problem statement. How to solve 1D beam problem subjected to tensile load in ANSYS workbench. A cantilever beam of 500 mm subjected to 10,000 Newton tensile load, having circular cross-sectional area with dia of 50 mm. Step-by-step procedure to solve 1D beam problem subjected to tensile loading in ANSYS workbench. Open ANSYS workbench, then select a static structure, then put the material what you are using, then click on geometry to draw, click on geometry and ODM, open design modeler, create a sketch, then convert that sketch into line body, create a circular cross section, link that cross section with line body, then open mechanical, generate meshing, then apply load, constraint, define output, then solve the problem, then lastly find the result of deformation and axial stress. We will solve that problem in ANSYS software. So open ANSYS workbench, and after opening of ANSYS, first you go through every tools or menu bar, and see what functions they have provided you. See here in toolbox they have provided analysis system, component system, custom system, various things. So in analysis system, from the name itself suggests, using this toolbox we can analyze the problem, whether it is a static or dynamic analysis. We can solve using this toolbox. So you can go through one by one. Today I am solving this problem in a static structure. So to take any of these analysis system, right click on it and drag to this box, or otherwise double click on this static structure. Now first option it is showing, and you see I have already told you that whenever you perform any analysis in this ANSYS or any software, please go through yourself and practice as much as you can. So see in this drop down you can see various things, various options. So this is the replacing with various analysis system. Like that, I taken a static structural from this toolbox, but I want to perform transient analysis. So from here only we can replace with that. We can delete this, we can rename this properties, all these things. We can duplicate this, that is copy that analysis system. Okay, so first of all we will go to engineering data. This here, structural steel, this is a default material of this software. This is the default material of this software. It is added. To add new material, I will tell you in further session. So see, go through this chart. Property of material, that is a steel, structural steel, that is density. Here is unit is provided. Isotropic elasticity, Young's modulus, Poisson's ratio, bulk modulus. All these things are available already. So now I will return to project. This project. Now we will go to draw geometry. So right click on this, open. Here two options is available: a space claim geometry and new design model geometry. We will draw our sketch in this option. So it will take some time to open. Let's wait. Now it is open. Here it is showing ready. So first of all we will select the unit. I will work in millimeters. Now then choose a plane and then right click on this, then look at option, then go to sketching, select line, draw a line of 500 because cantilever is of 500 mm. Here this H option is showing that this line is horizontal. So click anywhere, but you must take care that here must appear H, or if you, when you're drawing vertical, there must be V. Now we will go to dimension, general dimension. Here this is the details of the sketch 1. We'll put 500 mm. For fitting, then F7, press F7. Then after doing this, go to this concept, create lines from sketches, lines from sketches. So select this line, apply, then generate option is. So this here, line 1, that is sketch 1 is created. In this one part, one body is there, that is line body. Now what we have seen in theory, that we have to add cross-sectional area, cross-section. So from here go to cross-section. What type of cross-section we have taken? Circular cross-section of radius. What we have taken radius is dia is 50, so we will take the radius 25. Fit this to the screen, F7 by clicking on F7. Now go to this line body and choose the cross section, circular one. We have provided all these things. We have drawn the sketch. Now we have given the cross sectional to this sketch. Now we will go back to our ANSYS workbench. So double click on this model to open mechanical. It will take some time to open. So now this is a mechanical window in which you can see this tray. You can see this here geometry, that what type of geometry we have drawn, material, cross sections, coordinate systems, then mesh. We have performed the mesh already. So now we will add constraint to this cantilever beam. So first of all, applying load. See here, appearance of this element can be changed using this all things, this all options, like this. So the meshing, if we don't want to mesh, while applying force we should one care about at what point we are applying. So due to this meshing you can face some difficulty, so simply switch off this mesh and then you apply the force. So select this option, that is a vertex option to apply the force. So select this, apply the force. Now change this defined by vector, from vector to components. Now apply in x direction how much? 10,000 Newton. 10,000 Newton. Next is to apply fixed support on one end. Select this point, apply. Now what result you want to find? Directional deformation. Well, in which in this you can see the detail of this, that which directions you find they want to find the deformation. Here automatically it by default it has taken x direction. You can also find using this beam tool the stresses. See here, stresses, direct stresses you can find here. Now right click on this, solve. Now you can see the deformation here. So this is different color it is showing, because at red it is showing maximum deformation of this. It is in mm, unit is mm. You can see the directional deformation x-axis here. Time is also mentioned here. So now you can solve this problem analytically using this data, and you can verify that problem using this software. You can see the direct stress also, deformation. You can see the animation using this, how the beam is getting deformed. due to that applied load and constraint applied at other end. So these are all of the basic things. If you face any difficulty while solving this problem, you feel free to contact or write in comment box.